We've briefly discussed molecular and ionic compounds, and now comes a part that can kind of sometimes be a pain, and I know it's not going to be the most interesting lecture, but I'll do the best that I can to describe nomenclature. Because if you are going to communicate with chemists, you need to know their vocabulary. The nomenclature rules that we have weren't just simply slapped together and developed. They were put together with a lot of time and a lot of effort to try to figure out what is the best way to name these particular compounds that we're going to be analyzing when we put them together for chemical reactions. So when you're asked to name a particular complex, the first thing you need to do is we need to first determine if the compound of interest is ionic or molecular. And you should be saying to yourself, hey, I know how to do this. Ionic complexes are a metal and a nonmetal. We'll talk about this later, but in these compounds we have a transfer of electrons going on. A molecular complex or molecular compound is a nonmetal bound to a nonmetal. And in this case, we have the sharing of electrons going on. Chemically, these complexes are different, and we're going to use a different nomenclature system for each of these compounds. Okay? So first step, determine if your compound of interest is ionic or molecular. So we'll first then go ahead and talk about nomenclature for ionic compounds. If we have an ionic compound, we need to break these down into two categories. The first one is binary, and the second one is something that contains polyatomic ions. And these polyatomic ions can be found in table 2.5, and they're also on the flap in the back cover of your textbook. When we have each of these complexes, binary compounds can also be broken down into two main groups, where we have our main group compounds, which have the charges that we talked about and the groups in the periodic table we talked about, where we have the 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Then we also have to worry about transition metals, because transition metals can vary in oxidation state, or their charge can be different. Okay, so we must specify the charge, or later we'll call this the oxidation state. And this is important when we talk about transition metals, because main group cations and anions will always have the same charge. Transition metals are a little bit different, they're a little bit weird, so we kind of have to specify which charge they have. So if we're looking at binary nomenclature, binary meaning you have a cation and an anion, we're going to name this by listing the metal name first, plus the anion, then with an IDE suffix. Some examples of some binary ionic compounds are NaCl. NaCl, we list the metal name first, which is sodium. Then we have a space, and we list the anion name with an IDE prefix, or an IDE suffix. So this is going to give us sodium chloride. If, for example, we have BaCl2, we list the metal name, which is barium. and then list the anion name, which will be chloride. Okay? Notice that we don't need to put the 2 anywhere in for this chloride, because when an ionic compound forms, it's going to balance out the positive and negative charges. So anytime we have barium chloride, for every 1 barium, there's going to be 2 chlorides existing in that compound. We can also go from the name to the formula. So if we have lead hydroxide, if we look in the periodic table, lead is going to have a +2 charge. So lead hydroxide is going to have a Pb, which is 2+. Hydroxide, from that table in the back of your textbook, lists a -1 charge. So we're going to need 2 hydroxides to balance those out. When we write this chemical formula, the hydroxide molecule itself has the -1 charge. So we need to take lead and then 2 of these hydroxides. So we need parentheses around the O and the H to indicate that there are 2 oxygens and 2 hydrogens in that formula. The last example we'll look at is potassium sulfide. So if we have potassium sulfide, potassium is K. It's in group 1A, so it has a +1 charge. Sulfide is S. It's in group 6A, which has a -2 charge. So we need 2 potassiums for every 1 sulfur. We don't need a parentheses around the potassium or around the K because it is just 1 letter. So it's K2S. So this is how we would list all of the binary ionic compounds.